Good morning, ladies and gentlemen. Today's lesson is on the design process or the problem solving process. At the end of this lesson, students will develop leadership skills and work ethic. You should be able to demonstrate work ethics within the classroom and the laboratory environment. The design process is non-linear, unlike the scientific method, and has basically 6 steps to it. These steps include identifying the problem. To be able to solve a problem, you have to be able to come up with a solution to any problem. You have to be able to identify the problem. The next step is to collect information, also known as brainstorming. When you brainstorm, you use resources like talking to people who've already designed or built something. You can also use the library and talk to friends and your classmates and collect as much information about what you want to do. After collecting all this information, you develop solutions. You basically pick up the best solution, because you have multiple solutions, but you come to a consensus with your teammates and pick the very best solution. After you pick the best solution, you build what you call a prototype. A prototype is nothing but a model of what you want to build. After building the identical, it's like a model of what you really want to create, and or what some people call a replica of what you want to do. After building a model, you test it. You want to test and make sure it works. If it doesn't work, and since this is nonlinear, it's basically cyclical, you can go ahead and identify what caused it not to work, or identify the problem to the failure. Okay? And you can go back, collect more information, refine, and go over the process again until you get it right. Well, the universal or the systems model, you've already covered it. Every basic system consists of the input, the process, the output, and feedback. Identify the problem. When you identify you pretty much have to clearly define the goals, understand criteria and constraint, because you're going to run into problems. Criteria is what is required. What are the specifications for what you want to build or design. Then you're also going to run into problems, also called limitations or restrictions. Nothing is perfect. You're going to run into problems. Okay? So you identify the problem, collect the information. Collecting information, like I mentioned before, is to ask questions and conduct research. Who, what, when, where, and why. Collect as much information as you can. You also have to analyze your resources, like we covered previously under systems, technological systems. Analyze your resources. People, they're all part of your input to a system. Talk to people, get as much information about materials, tools needed to accomplish the task, machines, time needed to do it, energy, the power needed to run your machinery, capital is basically money, okay, needed to accomplish your task. Okay, develop possible solutions. In our case, I need more than one solution. Whenever I give you a problem, I need more than one solution to a problem. In our case, I require a minimum of 3. Okay, this is where we draw and sketch our ideas. Don't worry too much about how beautiful it looks. Just sketch your ideas on paper. These are called thumbnails or thumbnail drawings. 5 ways to develop solutions. As already mentioned, brainstorming, try and error. Sometimes, don't worry too much about if it's not going to work. Just try and error. And sometimes you come to solutions by accident, luck. And also your past experience can expose you to some, wonderful ideas or solutions. And insight. Choosing the best solution. Well, you get as many solutions from your teammates. You talk it over and isolate your choices, look at all the details, and vote on the very best solution. Your final choice actually depends on the resources available, and there are 7. This way you make your final decision, or your final design, excuse me. Your design should be neat and detailed. 7 resources of technology. Already mentioned: people, information, materials, tools and machines, time, energy, capital. Now we have to implement the solution, put the solution into action. Remember, implement is a verb. A verb is a doing word. That's where we do stuff. Here we do the solution, make it, build it, and try it out. This way we create a model, a replica, a copy, of what you want to make. Then after making it, you want to test it, make sure it works. Okay, it works. Okay, then you gather your feedback. That's in every system. You want to know if it worked, then it's okay. If it doesn't, then you want to go back to the input and maybe make some adjustments. Maybe you need some more capital, you need some more information, and so on. And consider what went well and what could be improved.